Assalamualaikum warahmatullahi wabarakatuh. Kita berjumpa lagi dalam video seterusnya. Pada video kali ini, kita akan membincangkan perkara melibatkan extrema of function of two variables, which is the last topic for this chapter 3, partial derivative. So by the end of this section, you as a student should be able to determine relative extrema of a function of two variables. Basically, there are long explanation when it comes to extrema of function of two variables on page 202 onwards. So basically, it can be summarized into this figure where imagine you have a surface, and on this surface there are so many points. So instead of we give characteristic for each point that exists on the surface, so we would like to consider, or we would like to determine the characteristic of a special point, and this special point we call it as a critical point. So the critical point can be categorized either it is a relative minimum, relative maximum, saddle points, or no conclusion can be withdrawn from that particular critical point. So there is a theorem involved when we want to determine the critical points of the function. And then there are also another theorem to talk about second derivative test. So if you look carefully on page 205, we have summarized the procedures or steps involved to determine relative extrema of functions of two variables. So the first steps involve by determining all critical points of the functions. The critical points of the functions can be obtained by equate the first order partial derivative, which are fx and fy, equal to 0. Sometimes the x and y coordinate can be obtained from the first order partial derivative, or you can solve the first order partial derivative, equate them equal to 0, and either by using normal substitution or solve both first order partial derivative equal to 0 simultaneously. And the second part would be, or the second step, you have to determine all second order derivative. If you go through topics 3.2 onwards, by right, the speaker has mentioned about second order partial derivative. For function of two variables, there are 3 second order partial derivatives, such as fxx, fyy, and fxy, and these values will be used to determine the second derivative test. And the second derivative test, the formula is fxx times fyy minus fxy squared. And then right after you perform the second order partial, the second derivative test, and then you substitute the critical point, and then you have to write a conclusion of each critical point. Either it will give you relative minimum, relative maximum, saddle point, or no conclusion. When you get the second derivative test and substitute with the critical point, when you get d larger than 0, which is positive values, you have 2 possibilities. The first one, you have to double check in terms of second order partial derivative fxx. If it is greater than 0 or positive, it will give you relative minimum. If fxx less than 0, it will give you relative maximum. And if the value of second derivative test, right after you substitute the value of the critical point, you get less than 0, which is negative values, you can say that it will give you a saddle point. Meanwhile, if d is equal to 0, you can safely assume that the critical point won't give any conclusion, which is no conclusion. Now, let's take a look at the first example 3.5.1. Okay, you have been given with this equation fxy equal to negative y squared negative 3x squared plus 10y minus 6x minus 4. So what should I do? The question will ask you to determine relative extrema. Determine relative extrema according to the steps that have been discussed earlier. Step number 1. Okay, let me write how to solve. Step 1. Find all critical points. So in this case, I have to determine fx first, which is first order partial derivative with respect to variable x. I let y as constant. So in this case, I will get negative 6x negative 6 and fy equal to negative 2y plus 10y. So both of first order partial derivative, you should equate equal to 0 in order to determine x coordinate and y coordinate to represent the critical point. So in this case, 6x equal to negative 6, x equal to negative 1, and in this case, this one is not 10y, my mistake, it should be 10. 2y equal to 10, y equal to 5. Therefore, the critical point for this case is negative 1, 5. And then I have to go to step number 2. Step number 2 asks me to determine all second order partial derivative. And second order partial derivative is given as fxx. So in this case, use this one, you will get fxx negative 6 fyy equal to negative 2 and fxy equal to 0. fxy is equal to fyx. It will give you the same answer. And then step number 3. Okay, step number 3. Second derivative test. Okay, let me bring it down. Okay, second derivative test. So d is equal to fxx times fyy minus fxy squared. So in this case, what is your fxx? fxx is equal to negative 6 times negative 2 minus 0, which is 12. 12 obviously larger than 0. When the value of second derivative test is positive values, there are two possibilities such as relative minimum and relative maximum. To be certain with your answer, you have to look at fxx. So in this case, fxx is equal to negative 6. And then we reach to step number 4, which is you have to write down the conclusion. Okay, for critical point equal to negative 1, 5, since d equal to 12 larger than 0 and fxx equal to negative 6. Therefore, CP equal to negative 1,5 is relative maximum. Okay, quite straightforward, quite simple. And let's take a look at the next example. Example 3.5.2. Determine relative extrema for function fxy equal to x cubed minus 3xy plus y cubed. Okay, don't worry, we go step by step. How to solve? Step 1. Find all CP's. So in this case, determine the first order partial derivative. In this case, I'll let y as a constant. I will get 3x squared minus 3y, and fy equal to negative 3x plus 3y squared. Then I have to equate both first order partial derivative equal to 0. See, so in this case, I will get y, wait for a while, 3y equal to 3x squared, y equal to x squared. And from the second first order partial derivative, I get negative 3x plus, since y is equal to x squared, I will replace y on the second first order partial derivative with x squared. So I will get 3 x squared equal to 0. Okay, so in this case, I will get negative 3x plus 3x to the power of 4 equal to 0. X negative 3 plus, or 3x, wait for a while, negative 3x 1 minus x cubed equal to 0. X equal to 0, or 1 minus x cubed equal to 0, x cubed equal to 1, x equal to 1. Okay, if you look carefully to this first order partial derivative, I get two values for x coordinate. X coordinate, I get two values such as x equal to 0 and x equal to 1. Since y equal to x squared, when x equal to 1, y equal to 1 squared. When x equal to 0, y equal to 0 squared. Therefore, I get two CP's such as 0, 0 and 1, 1. Since I have two critical points, I have to test these two critical point, whether it will give me relative minimum, relative maximum, saddle point, or no conclusion. Now, go to step number 2. Step number 2 asking you to determine second order partial derivative. In this case, okay, fx is equal to 3x squared minus 3y, fxx equal to 6x, fy equal to negative 3x plus 3y squared, fyy equal to 6y, fxy equal to fyx equal to 0. Okay, it is actually wrong. It's not 0. Okay, I have to refer to this one or this one. It will give me the same answer, since we have theorem mentioned that fxy is equal to fyx. So in this case, not 0, by referring to fx or fy, fxy is equal to negative 3. Okay, step number 3. Step number 3. Okay, step number 3 will ask you to determine second derivative test. So you simply put it into the formula of second derivative test, such as d is equal to fxx fyy minus fxy squared. In this case, you get 6x times 6y minus 3 squared. You will get 36xy minus 9. Okay, this is dxy. So step number 4, you have to write down the conclusion for each critical point. So step number 4, conclusion. The conclusion must be from the second derivative test. So in this case, at CP 0, 0, d00 equal to 36 times 0 times 0 minus 9 equal to negative 9 less than 0. Hence 0, 0 is not relative maximum but saddle point. At CP 1 times 1, not times 1 times 1, 1, d 1 equal to 36 times 1 times 1 minus 9 equal to 27. And 27 obviously larger than 0. Check fxx. fxx equal to 6x. fxx 1 equal to 6 times 1 larger than 0. Hence 1 is the relative minimum. So this is how you write down the conclusion. Now, let's try to answer one question from exercise 3.5 on page 207, and I choose to solve problem 3, which is determine all relative extrema for the following function fxy equal to 4xy minus x4 minus y to the power of 4. So, stay calm and try to recall all the steps involved to determine the relative extrema. So if you still remember, you have to go to step number 1, which is find all critical points. In this case, what should I do? I have to determine first order partial derivative first, and then both of the first order partial derivative we will equate it equal to 0 to determine x and y coordinate that represent the critical point. In this case, I will get fx equal to 4y minus 4x cubed, fy equal to 4x minus 4y cubed. Both of the first order partial derivative equal to 0, and then from the first equation you will get 4y equal to 4x cubed and y is equal to x cubed, and then substitute y equal to x cubed into fy equal to 0. Then I will get 4x minus 4 x cubed equal to 0. In this case, I will get 4x minus 4x to the power of 9 equal to 0. By factoring 4x, 1 minus x to the power of 8 equal to 0. For x equal to 0, x equal to 0. 1 minus x to the power of 8 equal to 0. Since x to the power of even number, not 0, sorry, 1, you will see that there are two possible values when you try to solve x to the power of 8, because it will give you plus minus 1. 1 to the power of 8 will give you 1. Negative 1 to the power of 8 will also give you 1. Therefore, two values when you try to solve for x to the power of 8 equal to 1. Okay. And at the same time, when x equal to 0, y equal to 0 cube equal to 0, x equal to 1, y equal to 1 cube equal to 1, x equal to negative 1, y equal to negative 1 cube equal to negative 1. Therefore, critical points, there are 3 critical points: 0, 0, 1, 1, and negative 1, negative 1. So you have settled the first step. Then step number 2, which is find all second order partial derivative. In this case, f(x) equal to negative 12x squared. Fyy equal to negative 12y squared. Fxy equal to Fyx equal to four. Then we go to step number 3. Step number 3, which is second derivative test. D of xy equal to fxx fyy minus fxy squared equal to negative 12 squared negative 12 y squared minus 4 squared. You get 144 squared y squared minus 16. Then step number 4, which is the last step, conclusion. Okay, maybe you can use a table. Zero, zero, 1, 1, negative 1. Okay, for the first critical point, okay, you will get negative 16. No need for you to test for fsx because obviously it will give you saddle point. Then go to the next question, which is for the second critical point, which is 144 times 1 times 1 minus 16. You get 1 to 8. Then since the value of D is positive, there are two conclusions that you can achieve when D larger than 0. You have to check for fxx. In this case, fxx equal to negative 12. Which is relative minimum. No, relative maximum. Okay. I believe the answer will be similar for negative 1, which is 1 to 8 and negative 12. Again, relative maximum. So this is how you have to do to solve problem that involve relative extrema or function of two variables. I really hope if you have time, you can go through the learning space and then try to do a lot of tutorial and activities that we have prepared and tailored according to your needs. So we have go through to an extent where we collect all questions that we have asked during test and final prior to each topic. So I really hope you can spend some time to go through all the tutorials and activities so that you get an idea and you can practice yourself on how to solve problem for each topic. Until then, thank you so much. And again, don't forget to click like and subscribe. Bye.